So with attributes, there's some terminology you need to be aware of. So we have our attribute table, and you'll hear us talk about attributes and attribute tables. The rows within an attribute table have three different names, and the reason for this is because they came from three different technical disciplines. So feature is the GIS term, where each row represents the aspatial attributes associated with a feature on the ground. Object comes from object-oriented programming. You won't see that a lot, except you may see an object identifier. And then record ID comes from the database world. So attributes can be stored in a database, and then you'll see some of the database terminology. So feature or attributes for a feature, and record you will hear periodically. Then you'll also hear columns of attributes or fields. Again, field comes from the database world, columns more from Excel and tables. So you will hear field, and you'll see that especially in ArcGIS Pro. Okay, and just remember that each row here in our attributes represents one feature in our shapefile. Here's a little table to summarize what I mentioned, is that you got spatial data with attribute table, an attribute for each attribute, feature ID, and each row containing attributes for one feature, and then each cell have an attribute value, and then you can filter the data. Within spreadsheets, we call it a spreadsheet with columns and row numbers, rows, and then cells, and then we can select within the spreadsheet. A database has tables, fields for the columns, record IDs for each record, and then the record itself being the row, and then entries within the record, and then a query to be able to query it. Object-oriented programming, again, you won't see this much. ArcGIS Pro, they seem to move away from exposing it because you used to see object ID, but know that that one is out there, and that's just the ID of the record, and you really don't have to worry too much about that. What you do have to worry about is table, field, record, row, the things that I have put in yellow. It's really common to see attributes of vector data. It's rare to find them with raster data, but you do see them sometimes in ARC with raster data. Names, populations or census numbers, vegetation characteristics, dates, coordinates, ownership, park types, these are all common attributes, and there's probably millions of different types of attributes out there. These are ones we could get for HSU, including bike rakes, which I think is supposed to say bike racks, trees, walking paths, classrooms, stores, etc. Labels tend to come from the attributes. You can label from the attributes and even put together combinations of attributes to create labels. You can do that, again, directly, or you can do it through symbology. So you can also symbolize your points and polygons with colors. You can even put charts on there. We can select using attributes and subset. All of these we'll do in the class, and these are all key things that we do with GIS data. So attributes are really foundational to our ability to do analysis and a whole variety of things with GIS data. Okay, so there's different ways of breaking up types of data. This is kind of an outdated mode. I don't see this used a whole lot, but you'll hear some folks talk about nominal data or unordered categories, so things like species and soil type, each type being not related to the others. Ordinal are ordered categories, so fire danger, low, medium, high, risk of flooding, low, medium, high, plant vigor, low, medium, and high. Those would be ordinal categories. So notice they don't have a meaning, like what does zero fire danger or low fire danger mean? It doesn't mean zero, it means low. So there's not a number associated with it, but they are ordered. Interval or continuous data, so it's not categorical, but there's no definite zero value. There are a few of these. In fact, folks talk about temperature, but there is actually an absolute zero on the Kelvin scale. So I'm not sure you really see a lot of these. What you do see a lot of is ratio. So this is similar to interval, except it has a zero value. So precipitation, population density, elevation, height. This is what most of our values are that we're working with in analysis. Our ratio, really we tend to call them floating point, right? Those are the floating point values we use a lot. One of the reasons this is important is because what you can do with them. With nominal, you can't do a lot. With ordinal or ratio really is the one we want. You can do anything you want, all kinds of different calculations. And then last but not least is cyclical. And these are things like time of day, day of the year. You'll see some of these with phenology or season, latitude and longitude, of course, repeat. However, we don't tend to do a lot of analysis with these. We do tend to do selection with them, but not a lot of analysis. All right, so these are a little bit important for structuring things. These data types are really important because this will determine whether or not you can represent the values that you need. Now, when I was young, we didn't have long integers and we didn't have doubles. So we only had things like unsigned bytes or 8 bits, which you could only represent numbers from 0 to 255. You don't have to worry about that anymore. In fact, you can get past all these issues by, if you have an integer value or need an integer value, just use long integer. And that's 64 bits. It can be a really big negative number or a really big positive number, 2 to the 64th, okay, which is 19 significant digits. It's huge. You probably won't need anything else, so use that. Now, that's for integers. Those aren't for math. Those are just for things like counting, number of trees, things like that. Double is the one we use more often for numbers. It's always signed, so it's plus and minus. You don't have to worry about that. It's 64 bits, and it can represent minimum from 10 to the 300th minus 300th to 10 to the 300th, which is crazy huge negative number to crazy huge positive number, and 15 significant digits. So for mathematical calculations, doubles almost always are good. As long as you use those two, long and double, you're usually in good shape. And we can't get any higher accuracy within a GIS package, so that's all we have. We also have dates, and I call them strings because I'm a programmer. Esri calls them text. It's the same thing, strings of characters or text. And then dates. The only really important thing to know about dates is there are different formats. Within the US, the month, day, year format dominates. Within Europe, day, month, year dominates. And if you have the 1st of January and you put it in the wrong format, I guess no one will care because it's 1-1. But if you had the 2nd of January, 1-2, in US, that goes over to Europe and that becomes the 1st of February. So we have to be careful with that when you're working internationally. One of the ways we avoid that is we use a standard like the database standard, which goes year, month, day, hour, minute, and second. Okay, so different date formats. Esri uses the US format by default. All right, where this becomes really important is when we set up our attributes in ArcGIS. And again, if you've got integers, use long. Floating point or numbers for calculations, use double. You're good to go. For strings, use text, and dates, use dates. And there's really, just if you use those 4, because there's only 6 options, you're good to go. When we work with other data types, especially rasters, you will find Esri uses a little bit different terminology. Signed 32-bit is actually a signed integer, and then they have floating point 32-bit for a float. They do not support 64-bit raster data types. The geodatabase format, long integer, is actually not the same as a long. It's a 32-bit, which is a problem. This is a 64-bit. And then they call this double precision floating point. Text and date are the same. So just watch for these name changes. With Esri products, you have to be careful because they do change names on the same thing sometimes. And then here's just some examples of attributes that you might want to pick. And it is really important if you're using things like a length or a coordinate value or an area or a temperature that you're using doubles so you have that fraction there for calculations. Otherwise, bad things happen. You lose the fraction. Okay, thanks.